Damian Brady is our first speaker. He is a professor of oceanography at the Darling Marine Center, focusing on how models can inform decision-making in marine ecosystems. Just take this in right here. His research spans aquaculture, offshore wind, Maine carbon dioxide removal, fisheries, and coastal water quality. His team develops and applies scientific tools to assess emerging ocean technologies and communicate findings to coastal communities. And one of the things that I ask all of these speakers to do is to give me a favorite pop culture sciencey thing that they like, just so we can make the point that they're all actually human beings who have other interests, possibly, although I do limit it to science. And Damian's choice was the life aquatic. Without further ado, Damian Brady.
Thank you. Thank you very much. This is the part of the talk where I would normally thank Kate for inviting me, and thank you all for coming out and saying it's an honor to be here, but I only have 5 minutes, so I don't have time. This is the Gulf of Maine, where we all live and recreate and enjoy the culture of. And I just want to make a point today that my name is Damian Brady. I'm here to quibble about grammar and how we describe the changes that are happening in the Gulf of Maine. But I'm going to start with just letting you know that this is probably one of the largest latitudinal gradients in ocean temperature in the world in terms of the Arctic and the Gulf Stream meeting at this place right outside the Gulf of Maine, right next door to us. And I'm going to impress upon you that the changes that we're seeing in the Gulf of Maine actually sort of take place a little bit further out to sea. Out here at a place called the Tail of the Grand Banks. And our journey collectively to figure out what happened to us roughly around 2008, which was a major change. This paper by Andrew Pershing, who was at Maine and GMRI at the time, described that the Gulf of Maine was warming faster than 99% of the world's oceans. So Andy went around the world looking at satellite imagery and then found out how fast things were warming, roughly the same size of the Gulf of Maine all over the place, and found out the Gulf of Maine was extreme in terms of its warming from roughly 2003 to 2012. Now, if the Gulf of Maine was warming at this rate from 2003 to 2012 to this day, it would be somewhere over here, which turns out to be boiling. So we are not currently warming faster than 99% of the world's oceans. We warmed faster than 99% of the world's oceans. And I think it's an important distinction that has really, really big implications for how we think about the future of the Gulf of Maine. This is a great plot from the Gulf of Maine Research Institute, and they point out that the Gulf of Maine is warming about 3 times the global average right now, if you take a look at 1980 to the present. But what I'm here to impress upon you is that if you really squint hard at this graph of temperature change in the Gulf of Maine, you should really notice that there's really 2 regimes. Before 2008, we were like this. After 2008, we were like this. And fitting straight lines to it actually doesn't help us understand what happened to us. And I'm going to try to make the case that it's really important. So what happened and why does it matter? Well, what happened is that we're at this real strong latitudinal gradient. We have this thing called the Labrador slope water, which is coming down, bringing water from the Arctic down here outside the Gulf of Maine. And then we have this other thing called the Gulf Stream, and it's bringing really, really hot water. So it's more accurate to think about the Gulf of Maine as a kiddie pool, and which is what I'm going to try to convince you of. The Gulf Stream water is really warm. The Arctic water from the Labrador slope water is really cold. The sun, actually directly heating the Gulf of Maine is playing a very, very minor role in what happens in the Gulf of Maine. It's rather the mix of these 2 waters. And I'm probably oversimplifying it because there's a third water that's really important, Scotian shelf water. So before 2008, from 2000 to 2008, we used to have this very large, warm slope sea that fed water into the Gulf of Maine with the Gulf Stream and the Labrador slope water coming down. But roughly 2020, so only a couple of years ago, we discovered after a lot of looking at satellite altimetry that what has now occurred is that the Gulf Stream is located more north. And instead of this Labrador slope water coming here and feeding us really, really cold water for our oysters and our mussels and our scallops and our lobsters, that Labrador slope water has been pinched off. So I'm going to use this analogy to keep the kiddie pool thing going. Our Labrador slope water has been cut off. We discovered this through some really cool satellite technology, Jason 2, which measures satellite altimetry. So it actually measures sea surface height from space. And from sea surface height, from space, we discovered that the sea surface height right at the tail of the Grand Banks has gone up. And when that goes up, this little blue line is less Labrador slope water into the Gulf of Maine. And before 2008, we used to have a lot more Labrador slope water going into the Gulf of Maine. And that's had huge implications. For instance, Calanus finmarchicus, our most lipid-rich zooplankton, goes down after 2008. Our young of the year lobsters that are settling into these habitats goes down post 2008. So either way, Damian, it's warmer. So why quibble around warming versus warmer? Well, understanding why it happened is going to help us understand what the future looks like. And clearly right now the future looks like we're going to come into this sort of predicted pause in rapid warming. We're not going to continue to go up at 3 times the global average, but probably over the next 10 years we are in the new normal, which is this very, very warm condition, which I think is important because many, many people in the marine environment make decisions on 20 and 30-year life times. And I'm done.
All right, if anybody, I'm going to just ask all the questions unless other people have questions. The microphones are here for you. We can start the clock. Hop on up. Please come on down.
Why 2008? Do we have any idea what conditions in 2008 made the change?
Yeah, we don't. It's easy to say that over the course of a lot of warming in the Gulf of Mexico that the Gulf Stream became stronger and meanders more, and if it meanders more north, it's going to cut off that water. There's a geological feature there at the tail of Grand Banks, right? That's the continental shelf. So that at some point, just having the Gulf Stream meander, which is what a lot of our weather systems are doing due to climate change, is simply going to sometimes pinch off that hose and sometimes not. So it's really the increase in variability from all of this super duper hot water from the Gulf of Mexico that's coming up and forming the Gulf Stream. The Gulf Stream is probably the hardest thing to predict in all of ocean climate models, period. Yeah.
Do you have any sense of, do we have to worry about it going another rapid increase, or do we just not have enough information?
Yeah, so the reason why I say this warming versus warmed is important is because we have to figure out if we're in for another step change. What I just described and showed to you is a 2 degrees centigrade step change in the Gulf of Maine. You know, we just had the Paris climate agreement to try to avoid 2 degrees Celsius, and guess what? It's already happened in the Gulf of Maine, and it happened almost overnight in 2008, 2009, 2010. So we've seen it first. We're the canary in the coal mine. It doesn't appear as if most of our models are saying that there's another step change in our future, which is why I sort of brought up the latest downscale models that show over the next 10 years we're going to be in this new super warm normal, but not another step change from whatever we can predict. Although I will tell you that none of us predicted what happened in 2008. So you can only trust us as far as you can throw us.
Are there any other locations that have the temperature monitoring that might have the same, correlate the same changes, or in history? I mean, I know some of these sea surface data go back pretty far. Have you seen any reanalyze things that were steps that you could think
Yeah.
of the same effect happening?
Yeah. Nothing with fine enough temporal resolution to see huge step changes like this. One of the things I'm super interested in the future is what happened at the tail of the Grand Banks when they analyzed it. They determined that it took about a year for the water that's circulating at the tail of the Grand Banks to influence the temperature in the Gulf of Maine. So a lot of us are wondering, shouldn't we have an early warning system? Working with folks in Canada and satellite altimetry that's actually real-time process, not 5 years later, for instance, and actually understand, well, we have a way of predicting what's going to happen to us a year in the future, right? If we did a really good job of monitoring that area of the ocean.
What are the implications for the development of offshore wind?
That's a very good question. Let's put it this way. The implications for offshore wind are much more political than they ever will be climate. Yeah, that's a difficult one to answer. Obviously we would, I think, all love to cool the earth down a little bit and move to renewable energy in some way, shape, or form.
I know that salination is changing of the ocean. What is the impact potentially on this process of that?
Yeah, so We don't talk about it nearly as much, but when the Gulf of Maine did that step change in warming, there was also a step change in the increase in salinity, so the water got a lot saltier. That shouldn't be a big surprise, right? Because the Gulf of Mexico and the Gulf Stream is a much, much more salty body of water. What happens with the changes in salinity, and the important piece of change in salinity, is it changes the density of seawater, which in turn can change mixing. And so it's a more subtle story, but and also an important one.
Thank you, Damian.
Okay, thank you.